Hey guys, welcome to the last lesson of this unit, lesson 5. Today we are going to be finding the intersection of polar graphs. So think about it. Whenever you've worked in the past with systems, what did you do? You set the two equations equal to each other, right? And the points of intersection are your solutions. So that's basically the same idea we're working with here, but we have a few more things to take into consideration. Since each point in the plane has multiple representations in polar coordinates, solving for the points of intersection of two polar curves may require more than solving an equation. And that's what exactly I said. So first of all, I'm going to look at my equations. I know the first one is a circle with a radius of half, or I can say the diameter of 1 because that has 1 here, right? And the next one is a limacon, an interloop limacon. So you can pause the video and graph them using a calculator. I'm just gonna quickly sketch them here. So my first one I'm gonna color code them, and it'll be good for you to color code them too. It's gonna be a vertical circle. It's signed with a radius of half. So I'm just gonna do half is here, half is here. So that's what my circle should look like. Right? It's just a sketch, guys. You can, again, use the calculator. I'm just trying to sketch it here. And this is an inner loop limacon. I'm just going to write that. Inner loop, right? So what is it? I need to know my a plus b, my a and a minus b, which is 3, 1, and 1. So I'm going to take a red color and do that. So it's a sign and it's positive, so it's going to be vertical. So these are my 4 points. 1 on the opposite axis and then 1 here. So I'm going to try to sketch it at, it's really hard with the Apple Pencil. So if you had graphed it, this is what it would have looked like on the calculator. So anyways, these are my 2 graphs, and if you were to look at the points of intersection, I'll take a green color and see tentatively 1 is here. I see 2 points of intersection. So but we need to know them algebraically, because not always they might be true, or there are multiple representations of writing the polar coordinates, so you need to focus on that. I want you to copy this in order to find the intersection at pole. And pole is the origin, okay? Intersection at pole. If both, you know, the curves intersect at the pole if both equations have r equals 0. So substitute r for 0 for any or some angle. And I'll show it to you. What does that mean? So the first thing I'm going to do is check for pole, whether the pole is a point of intersection or not. So that's my first thing. How do I do that? I take my each equation and set it equal to 0. So r, not r, my bad. It's just sine theta. So give me the theta values. Theta would be 0, pi, and 2 pi, right? Now, so I did get an angle, some angle or any angle, right? That's what it said. I'm going to switch colors, actually. I'm going to take yellow, and I'm going to put this other equation, 1 plus 2 sine theta equal to 0. And if I solve for sine theta, what do I get? Is negative half. So theta would be what? 7 pi. Sine is negative in the 3rd and 4th quadrants. So it's 7 pi over 6 and 11 pi over 6. So these are our, so we did get an angle. So yes, it does intersect at the pole. So I already know pole will be my point of intersection. That's my one thing. Right now I want to find out the other one. I just showed it how I find that. So now if you want to find the other remaining points of intersection, what you do is take the 2 equations, and I'm going to try to do it in a different color, and set them equal to each other. So I'm going to do sine theta equals 1 plus 2 sine theta, right? And you want to solve that, move the sine theta over. So what do you get? Sine theta is equal to negative 1 So for where is sine negative 1? It is negative 1 at 3 pi over 2. So you got your theta, but you need to find r. What do? You can actually take this theta, and I'm just going to write that in here. Substitute into any equation and find r to get r. Okay? Oh, I didn't put quotes, I did brackets. So I can do any, but the first equation looks much simpler. So I'm just going to substitute that. So if I do, sine of 3 pi over 2 is negative 1. So my r is negative 1. So now my points of intersection are the pole that we already wrote here, and negative 1 comma 3 pi over 2. And you can check. This point is negative 1 comma 3 pi over 2. If you were to say, why can I not use 1 comma 3 pi over 2, you can always substitute that back into the equation. So let's say substitute it. I'm going to substitute into here, and it doesn't work. So 1, your r was 1 plus 2 sine theta, sine of pi over 2, right? So we're going to do 2 sine pi over 2. So we're checking. This is your check, that if it works or not. So this one works. So when you are checking, you're not you're not moving things onto the other side. You just substitute theta and see if it works. So this would be, what is pi over 2? 2. 1 is not equal to 3, right? So that is the reason why 1 comma pi over 2 does not work. It's not a solution. Only this is. So if you want to write that 1 comma pi over 2, you were checking for this point. That's like a question mark. So it doesn't work. So these are your two solutions. Okay, so let's get started. Do example 2. If you want to pause the video and see how far can you get with the question, graph it using your calculator, and then we'll take it from there. So your first one, this is the equation of a circle, right? So I'm going to write circle here with a diameter of 2, means radius is 1, and the other one is a cardioid because your A and B are. So I'm graphing the circle with a center of, I would say, radius of 1, right? And it's a sine, so it's going to be vertical, right? That's where my thing is. Now I'm going to do the cardioid. It's a cosine, it's positive, so those are my 3 points. It's going to be here and here, right? I start at the pole and I go around. I'm going to try do the best I can. These are hard to graph like in one. Oh, I think I did a pretty decent job, right? Okay, so how many points of intersections do you see? 2. So first thing we always do is check pole. So let's get started with that. Check pole. How do we check pole? We set each equation equal to 0 and solve for theta. So what is theta? Theta is 0, pi, and 2 pi, right? So now let's do the same thing to the other one. So 2 plus 2 cosine theta equals 0. You get cosine theta is equal to -1, right? I skipped a few steps. If you're confused, let me know. It's subtract 2 and then you divide it by 2, so you got -1. So theta is, where is cosine -1? At pi. You got some angles, so yes, the pole is a chart. So it is intersecting at the pole. So again, so I'm going to write it here. So I know my pole is my one point of intersection. Now I want to find my other point of intersection, which I can see here. There are 2 points of intersection. One is here and the other one is here. So I just want to find out what it is. So what you do is you take your 2 equations and set them equal to each other. So I'm going to rewrite it and change colors actually. Let's do black. So 2 sine theta equals 2 plus 2 cosine theta, right? So this is a little challenging because I really can't, they are not the same trig functions. So if you remember from your previous lessons, if you get a different function, it's not in the equation is not in one function, you might want to substitute so that you get the equation in one function and it's easier to solve. Before I even do that, can I square both sides? What will that do is, this would be, I'll change colors, 4 sine square theta, right? I hope you're seeing what I'm getting. And this is a plus b square basically. So this would be 4 plus 8 cosine theta plus 4 cosine square theta, right? You write the quantity twice and you double distribute. That's what I did. So now, can I substitute sine squared theta with what? 1 minus cosine squared theta. Yes, so it would be what? 4 times 1 minus sine, 1 minus cosine. 1 minus cosine squared theta equals 4. That way I will have an equation in cosine and it'll be easier for me to solve, right? Now this is pure algebra. This would be 4 minus 4 cosine squared theta equals 4 plus 8 cosine theta and 4 cosine squared theta, right? You can pause the video and try to solve it and check your answer with mine. I'm just going to continue solving it. So the 4's actually cancel out, right? And if I set it equal to 0, I get what? 8 cosine. I'm just going to zoom in so I get more room. 8 cosine square theta equal plus 8 cosine theta equals 0. So do the GCF, you get 8 cosine theta and you're left with what? Cosine theta plus 1. You can't factor them further, so make up your t-chart. So this would be what? I'm just going to rewrite it. Equals 0, so I get cosine theta equals 0. So theta is what? Pi over 2 and 3 pi over 2, right? That's where cosine is, for those values, theta, cosine is zeros. And now I'm going to do the same thing. I'm just going to change color. So I get cosine theta plus 1 equals 0. Cosine theta equals -1. For what theta value is cosine -1? It is pi. Now you got your theta values. Now you want to substitute them into one of any equation. You can pick the circle or the cardioid. Doing the circle is so much easier. You can do that in your head. So I want to substitute in there and find my R value. So what do I get my R to be? So let's do this. So if you want me, I'll show it to you here. So all I'm doing is R is equal to 2 sine of pi over 2, which is what? 1, so I get 2. If I substitute the next one, 2 times sine of 3 pi over 2. Sine of 3 pi over 2 is -1, so 2 times the -1 is the -2. And if I substitute pi, I get 0. So which is right here, pole 0, 0. So now, once you have this, you want to write down your angle. So it's going to be 2 comma pi over 2. Isn't 2 comma pi over 2? This is 2 comma pi over 2, which we saw that, right? Isn't it same thing as -2 comma 3 pi over 2? And I already did the check and they work. You can always check them into the equation and they should work. So these are your two solutions. Okay, so they are a little intense, but there's a process to it. And if you're confused with anything, let me know. Finish the remaining packet for homework and let me know again if you have any questions. Good luck, guys. I just realized that I did not write it as a ordered pair. So that's it.